This is Project 2.7 Medium ISP. This video presents a wireless weather monitoring system consisting of a transmitter and a receiver. The goal of this project is to collect environmental data using sensors and transmit them wirelessly to a receiver unit for real-time display on an OLED screen. The transmitter receives 3 data points. The humidity and temperature are collected with the AM2320. The UV is collected with an Adafruit UV sensor, and then both of these data points are collected and sent through SPI communication to the NRF24L01 radio to the receiver module. The receiver receives this information with its NRF24L01 and displays the information on the 128x64 OLED in real time. Both the TX and RX communicate with the NRF24L01 via SPI. Unique pipe addresses are used to ensure reliable point-to-point data transmission. The AM2320 digital sensor communicates over I2C to provide both temperature and humidity data to the Nano. I read UV rays using the Adafruit UV sensor. This sensor has analog voltage proportional to the amount of UV rays it is being exposed to. I read these analog voltage using an analog read function as seen here. I take the analog read value and multiply it by the voltage reference divided by 1023, and this gives me the true voltage value from the UV sensor. I then divide this number by 0.1 or multiply it by 10 to obtain the true UV value of the surroundings. The sensor data is organized using a struct. This allows for multiple data types to be grouped and sent as a single packet over the radio. The packet is transmitted with radio.write add data, which is a pointer to data, and size of data telling the radio how big the data it's sending is, and is received the radio read with similar values passed to it. The receiver receives the data and displays it on a 128x64 pixel OLED using I2C communication. Text formatting is managed by setting the cursor, text size, and color, along with a large amount of other commands to display the information in a comfortable way. The display updates dynamically based on receiver values coming in from the transmitter. The push button found on the left side of the OLED on the receiver allows the user to cycle through 3 display pages: the temperature, the humidity, and the UV index from data received from the transmitter. This is handled using a hardware interrupt. This is done by the button being a high by default, and then when the button is pressed, D2 is pulled to low, creating a falling wave. This falling wave is attached to the interrupt and tells the computer to change the slide. There's also a debalance circuit on this interrupt to ensure a more consistent interface for users. The final part to this project is creating graphics on the screen. This is done by drawing something or getting a screenshot of something and turning it into a pixelated bitmap in hex code that can be put into the OLED screen to create said graphic on the screen.